Now let us start. Chemical properties of metal in detail. You know that metals when reacts with oxygen form oxides of that metal. So this is the first chemical properties. In your textbook it is given on page number 41. When metal reacts with oxygen, it forms oxides of that metal. Metal plus oxygen gives metallic oxide. As for example, sodium when reacts with oxygen forms sodium oxide, Na2O, sodium oxide. See, in 9th standard you have learned that sodium positive 1 ion, oxygen minus 2 ion, 2 right here, 1 right here, so it forms what? Na2O, sodium oxide. If you want to balance, then sodium is 2 here multiplied by 2, oxygen is 2, so multiplied by 2. So now sodium becomes 2 2s are 4, so now here multiplied by 4. So equation is now balance. Okay, so metal when reacts with oxygen form metallic oxide. As for example, another example is suppose copper when reacts with oxygen it forms copper oxide. Cu plus 2 oxygen minus 2, if both are equal no need to cross, if both are equal no need to cross, so CuO here multiplied by 2, so 2 oxygen, so copper will be also 2, so 2. Now aluminium, as for example, aluminium reacts with oxygen form aluminium oxide. What is the formula of aluminium oxide? Al2O3. Aluminium ion plus 3, oxide ion minus 2, 3 you have to write here, 2 you have to write that. So Al2O3, now how to balance it? So multiply this term by 2, so 2 3s will be 6, so multiply this term by 3, 3 2s are 6, now aluminium will be 2 2s are 4, so here 4. Many examples that you can give like this, okay? In short, you have to remember that metal when reacts with oxygen, it forms metallic oxide or oxide of that metal. Now remember another thing. Oxides of that metals are basic in nature. Means these oxides are basic in nature. When they react with water, it forms base. So metallic oxides are basic, like sodium oxide Na2O plus water, it forms what? NaOH, sodium hydroxide. 2 sodium, 2 hydrogen and 2 oxygen multiplied by 2. Now the equation will be balanced. So metallic oxides are basic oxide. Aluminium oxide Al2O3 when reacts with water it forms aluminium hydroxide AlOH thrice multiplied by 2, so oxygen 3 and 3 times 2, 3 2s are 6, hydrogen 3, 3 times 2, 3 2s are 6, so 3 3 6, hydrogen also will be 3 2s are hydrogen, 3 2s are 6, oxygen 3, 3 1s are 3, 3 plus 3 6. So in this way we can judge that metallic oxides are basic. You can give any example, means out of this 2 you can give one example only. In exam you have to write only one example. No need to write that here it is given, okay? You can write your own also. So metallic oxides are basic oxide. Now these oxides can react with base as well as react with acid. Sometimes, generally it is said that oxides are basic oxide, but some oxides are there that they can react with acid as well as base. So this type of oxide like aluminum oxide and zinc oxide, they are known as amphoteric oxide. See, oxides of metal can react with acid and base. then they are called amphoteric oxide. As for example, aluminium oxide and zinc oxide. As for example, okay, means aluminium oxide can react with acid as well as base. Mean they react with both, so they are known as amphoteric oxide. Aluminium oxide Al2O3 when reacts with acid, as for example hydrochloric acid, then it gives you salt AlCl3 and water. If you want to balance it, then multiplied by 2, 2 3s are 6. So multiplied by 6 here, 6 hydrogen, multiplied by 3, 3 2s are 6. Oxygen will be 3, here oxygen is 3, chlorine is 6, chlorine is 6. Is it okay? So in this way you can balance it. Aluminium oxide, it can also react with base. Al2O3 reacts with base like NaOH. Again it forms salt and water. Salt is sodium aluminate, NaAlO2, and water is formed. This is what? Sodium aluminate. Okay? This is aluminium chloride. Now if you want to balance, aluminium is 2 multiplied by here 2. So sodium will be 2 also, so multiplied by 2. Now check about hydrogen and oxygen. First check hydrogen, 2 ones are 2 hydrogen, so 2 is already there. Here 3 oxygen and 2 ones are 2. 3 plus 2, 5 oxygen on left side, that is reactant. In product, 2 2s are 4, 4 and 1, 5. So in this way we can find that the reason is also, it will ask that aluminium oxide is an amphoteric oxide. Explain. So you have to explain the definition of amphoteric oxide, and then you have to give the example why this aluminium oxide reacts with acid as well as base and form what. Is it okay? Now each and every metals are not reacts in same manner because their reactivity are different. Some metals are highly reactive, some metals are less reactive, and some metals are moderately reactive, and that's why the reactivities are different. On the basis of their reactivity, we can say that these are the general example. It doesn't mean that these are the rule. Okay? Afterwards, in your future, when you learn about chemistry deeply in 11th standard, 12th standard, or in your graduation or post-graduation program, then you will see that these are the basic thing, and on this basic thing you can learn afterwards. Okay, so exceptions are always there. So metals such as potassium and sodium reacts vigorously, means fastly, that they catch fire, and that's why they can keep in kerosene. Sodium, that is called Na, and potassium, K, can always kept in kerosene. Why? Because sodium and potassium reacts with oxygen or air vigorously. Vigorously means very fast. Okay, so reason, because sodium and potassium reacts with oxygen O2 of air vigorously, but they cannot react in kerosene. This means they cannot expose in presence of kerosene. okay, a coating of kerosene is there on the sodium and potassium, then they cannot react with oxygen or atmospheric oxygen, and that's why sodium and potassium is always kept in kerosene. This is the reason. In the same manner, copper also form copper oxide, black color copper oxide, okay, Cu2O. If black color copper oxide is formed, then the coating of this copper oxide on it prevent the reaction with oxygen, so further oxidation cannot take place. Once copper reacts with oxygen, copper oxide is formed, but afterward, when black color copper oxide is covered over the metal, then it cannot further react with oxygen, and so you can say that oxidation will stop. Okay, so these are the basic things of chemical properties of metal. Now some other chemical properties of metal, that metal reacts with water. How? Metal reacts with water and form metallic oxide, and hydrogen gas is released. Metal reacts with water, it forms metallic oxide and hydrogen gas is released. One line question. As for example, some metal, in the question name of the metal is given sodium. Sodium reacts with water, H2O. Which gas is produced? Hydrogen gas is produced. Any metal, generally, any metal reacts with water, it forms hydrogen gas. This is the general form. Exceptions are always there, as I told you. Metallic oxide, when formed, this metallic oxide when reacts with water, it forms metal hydroxide, means base is formed. Metallic oxide when reacts with water, it forms what? Base. Metallic base is formed, right? As for example, potassium, sodium you can take. As for example, sodium when reacts with water, it forms metallic oxide, sodium oxide, and hydrogen is released. 2Na, 2H and O. Okay? Potassium, suppose when potassium reacts with water, it forms KOH, potassium hydroxide, and some amount of heat energy is also formed. Potassium when reacts with water, it forms what? K2O, potassium oxide, and hydrogen gas is released. This metallic oxide when reacts with water, Na2O plus water, then it gives you base NaOH 2 times. In your textbook, one equation is given wrong, so don't follow it. You have to follow this one. On page number 43, it is given little bit wrong. Now, calcium when reacts with water, it forms calcium hydroxide and hydrogen gas is released. Same manner, aluminium, iron, zinc, they do not react either with cold or hot water, but they react with steam and form metal oxide and hydrogen. Remember here that aluminium, iron, zinc, they do not react with cold or hot water, but they react with steam. Steam means water vapor, and so its equation is different. That aluminium when reacts with steam means H2O, Then it forms aluminium oxide, Al2O3, and hydrogen gas is released. 2 3s are 2 2s are 4. Okay, or you can write like this: 2 aluminium plus 3 H2O. It gives Al2O3 plus 3 H2. Then also both are right. They are balanced chemical equation. Iron also, when iron reacts with water, then it forms Fe3O4, ferric oxide, and hydrogen gas is released. Okay, 3 Fe, 4 oxygen, 4 2s are 8, 4 2s are 8. Okay, so these are the exceptional case. Now what happens when metal reacts with acid? Metal generally reacts with dilute acid. Metal reacts with dilute acid. Okay, and forms salt, and it releases hydrogen gas. Salt and hydrogen gas. As for example, sodium. When reacts with dilute hydrochloric acid, it forms NaCl, salt, hydrogen gas is released. Okay, so generally metal reacts with dilute. Hydrogen gas is always released when metal reacts with dilute acid, but the exceptional case is what? Nitric acid. Exceptional case is what? When metal reacts with nitric acid, HNO3, then sodium nitrate is formed and water vapor is released. Here, remember, hydrogen gas is not released. The reason is what? Because nitric acid, this is called what? Nitric acid is strong oxidizing agent. And that's why it never produces hydrogen gas. This is the reason also, an exceptional case also. Now, metals reacts with solution of other metallic salt. How they react with other metallic salt? In your textbook, on page number 45, an activity is given, that reaction of metal with salt solution. As for example, if you take iron nail, means iron, with salt solution of metal, that is copper sulfate, and vice versa, if you take copper and salt solution of iron sulfate, that is called FeSO4. Now what happens? Salt solution and metal is released. See, the vice versa thing. Fe reacts with SO4. Here FeSO4 is formed and copper is released. Here copper reacts with sulfate. Copper sulfate is formed and iron is released. Okay. So in this way we can get that when metal reacts with salt solution of other metal, then it displaces the metal. Why it displaces the metal? If the metal is more reactive, then the reactive metal can displace less reactive metal. This is called displacement reaction, which you have learnt in 9th standard. On the basis of this displacement reaction, we are going to learn about reactivity series. Okay, so this is the also important reactivity series on your page number 45.